Hi, welcome back. So today we will go into the first chapter of S2, which is on hypothesis testing. So the idea of hypothesis testing is to see how likely is a certain claim to happen by chance or it is statistically significant. So what is hypothesis testing? It tells you how likely it is for a certain claim to happen by chance, or whether or not that claim is statistically significant. So then the claim would be called a hypothesis. So basically your hypothesis will be your claim. So now, because some probability or statistics happen in this particular scenario, so it is very unlikely that the claim that you are testing, you can absolutely sure that it is true or it is false. But what you can say is that this particular test show that the probability of this certain claim or this certain hypothesis happen by chance is very small, that you can either reject or you can either accept the claim. So in short, hypothesis is your claim, and then statistically speaking, it is unlikely to be absolutely certain. About the true or false of a certain claim, but instead what you can say is you are statistically confident that whether a certain claim should be rejected or accepted. So in this particular claim, you have some names that you need to remember. The first thing is what we call as a null hypothesis. So basically, we label this as hash naught, and this is your claim. Then you have what we call as the alternative hypothesis. Which we call as hash 1. So if you reject your claim, then basically you have to accept this particular alternative hypothesis. So if you reject hash naught, then you have to accept H1. So that's the nature of hypothesis testing. So both of these hypotheses, they are based on statistical parameters, and particularly there is this idea of critical region, or sometimes it is called the rejection region. Whereby this is a region that you would reject the claim. Reject H0 basically. So if you have rejection region, of course you have acceptance region. So this will be the region that you will accept H0. So because of these two regions, so the value that determines which region is the acceptance region, which one is a rejection region, we call it as the critical value. So basically this is the value that sort of like determines where you would reject H0. Then you also have what we call as the significance level. Basically, this is the probability for you to reject the claim. So let's say this is your bell curve. So let's say your significance level is 5%, then this part should take you around 5%, and the dotted line here will be what we call as the critical value. If it is a continuous variable, then you can decide the critical value quite accurately. But if it is discrete random variables, then you need to test, because sometimes the critical value falls in between the discrete values. Then you need to test it out, which one sort of like gives you the true critical value. We'll see some examples later on. So the one that I sort of like shaded will be the critical region, whereas the other side will be the acceptance region, for example. It depends on what kind of test you are doing. So this particular example is what I call as the right tail test. So this is one example of one tail test. Specifically, I'm testing the right tail. So it'll be clearer if we look at some examples. So let's first define what are the general steps that you need to do. Steps. First thing, you need to look at the question carefully and define your random variables and your parameters. So if you are doing binomial distribution, then the parameters will be n and p. If you are doing normal distribution, then it will be the mean and the standard deviation. So this kind of things you need to be careful. Second, you need to define your hash naught and hash 1, your null hypothesis and alternative hypothesis. So over here, you need to be careful because depending on what kind of test you are dealing with, sometimes you have directions. So if you have directions, then this will be the one-tailed test. If you don't have any directions, then it will be two-tailed test. So whether or not you have a certain direction. The third thing, find your critical region. Then find your test statistics. And then you might be able to find the critical value. Sometimes they ask you to find the critical values. Finally, perhaps you do a conclusion. So it depends on what the question asks you, but generally these are the things that you need to find. So now let's look at some examples. So usually the questions are quite long, so I type it out first. So the first example, a television channel claims that 25% of the program are natural programs. Xavier thinks that the percentage claim is too high. To test the hypothesis, he chooses 20 programs at random. So just as a first glance, you know that, okay, first thing you need to define your random variable. So let's say x is the number of natural programs. So once you define this, you need to figure out what are the probability distribution. This is quite obviously a binomial distribution. So your n will be 20. You have 20 programs. And the claim is that your 25% will be natural programs. So naturally speaking, your probability of success will be 0.25. So now you need to define your hash naught. Your null hypothesis is basically P, which is your probability of success, will be 0.25. So he thinks that the percentage is too high. So it means that your null hypothesis would be, this is actually less than 0.25. So these are the things that you need to define. How you define hash naught and hash 1 depends on the question. In this particular question, he thinks that the percentage is too high. So naturally speaking, your hash 1 always tells you the direction. Because then if, let's say, when you test your hypothesis and it doesn't really support your null hypothesis, then it means that your alternative hypothesis is true. So now the test is at 10% significance level. So this is what you need to remember. Okay, so the significance level is 10%. Or you can write 0.1. So now you need to test. Suppose there are only 2 natural programs. So the direction is to the left because he claimed that this is too high. So what you need to calculate is px smaller or equals to 2. If this particular probability is less than your significant level, then it means that you need to reject your hash knot, and indeed there are fewer natural programs than being claimed, which is 0.25. So you can just calculate using your binomial distribution. X equals to 0, x equals to 1, x equals to 2. When you calculate everything out, sorry, this is plus, you find that this is 0.0913. So this will be the test statistics. So what are the conclusions? So since px smaller or equals to 2 is smaller than 0.1, which is your significant level, so then your n equals to 2 is a critical value, and you need to reject your null hypothesis and say that there are fewer natural program. Sorry. So if your significance level is 5%, what kind of conclusion that you can reach? So then px smaller or equals to 2 is actually greater than 0.05 due to this particular fact. So you need to accept hash knot. The underlying sentence that you need to write is basically this: there is insufficient evidence to reject the claim. So now, for example, if you want to find the critical values for the significant level, which is 5%, then you need to calculate out each of these individual probability. So px smaller or equals to 2, we already know that this is 0.0913. So let's look at this. So this will be px equals to 0 plus px equals to 1. So n is 20. Px equals to 0, if not mistaken, is 0.0032. Px equals to 1 will be 20c1 times 0.25 times 0.75 power 19. So this is 0.0211. Let's put it at 4 decimal places. So this is less than 5%. Let me double check. Something doesn't seem right. Okay, so let's break it down. It's 20, 0.25. So the first one is 20C 0. Sorry, I'm doing this while recording because I forgot to write this down. So this is indeed 0.0032. And this is 0.0211. So the reason why I'm unsure is because I need to test out the one above. So by right, this should be 0.0032, 0211. Okay. Yeah, it's correct. So somehow I calculated something wrong just now. So this is 0.0913. Okay, so let's continue. So this is 0.0032, 0211. So this is basically 2%. So this is less than 5%, which is 0.05. So 1 n equals to 1 will be the critical value. So the critical value tells you when you need to reject the claim. If let's say the question asks, but I don't think the question asks you over here. So this part of the calculation will be just something extra. It's not really necessary. Okay, so let's look at question 2. A farmer finds that 30% of the sheep are deficient in a particular mineral, changes the feed and tests 80 sheep to find out if the number has decreased. Define the random variable hypothesis. Use approximation and carry out hypothesis tests. Given that 19 are mineral deficient. So the first thing that you need to do is to define your random variable. This will be the number of sheep deficit in the mineral. So this is still a binomial distribution. You have 80 ships and then the probability of success is 0.3. So the question asks you to use a suitable approximation, meaning that you need to approximate using the normal distribution. So can you do it? If you find NP, this is 24, and Q would be 80 times 0.7, 56. So both are greater than 5, so definitely you can do it. So X will be approximately normal by 80 times 0.3, 80 times 0.3, and then times 0.7. So this is an 24, 16.8. So you are given the significant level, which is 10%. Or you can convert it to 0.1. So now you need to define your null hypothesis and alternative hypothesis. Your H naught, you can say that, okay, this is the one that you need to test. To find out if the number has decreased. Decrease, it tells you the direction. So for your null hypothesis, you don't always write the direction. So always remember your null hypothesis is equal sign, and then your alternative hypothesis is the direction that you want to test. So your null hypothesis will be P equals to 0.3. H1 will be P smaller than 0.3. So this is the one that you need to test. So alternative hypothesis always comes from the question. The direction will be given by the question if it is a one-tailed test. So now you can try to find this. So carry out the 10% significant level, and you have 19 ships. So that's why I wrote here px smaller or equals to 19. And you need to approximate using normal distribution. So because of the equal sign, you need to use 19.5 instead of 19. This is your mean. And then your standard deviation will be 16.8, square root of that. So after you do the calculation, you find that this is minus 1.098. Just check your table. And if you still can't see it, draw the bell curve. So this is minus 1.098. And this is the region that you want to find. So this is basically the same as 1 minus pz smaller or equals to 1.098. Okay, so that's why you have 1 minus 0.864, and this is 0.136. So this is actually more than 0.1. So since px smaller or equals to 19 is more than 0.1, there is no evidence to reject your claim. So now you need to work out the critical value. There's no sort of like easy way to do it, but since this is a discrete random variable, you can start with px smaller or equals to 18 instead of 19 and see what is the value, because the probability that you calculate over here is quite close to 0.1. So you might expect that 18 will be the answer. So doing the same approximation, because of the equal sign, you use 18.5 minus 24 and then divide by square root of 16.8. So this is pz smaller or equals to minus 1.342. So similarly, this is 1 minus pz smaller or equals to 1.342. And after you calculate this thing out, this is 0.0898. And this is smaller than 0.1. So since px smaller or equals to 18 is smaller than 0.1, which is your significance level, therefore the critical value is 18. So that's how you find your critical value. So let's look at the third question. A darts player claims that he can hit the bullseye 60% of the time. So now a fan thinks the player is better than that. Define the random variable, hypothesis, blah blah blah. So your random variable, let's put it as x, will be the number of bullseye the fan can hit. So this is still a binomial distribution. You are throwing 7 darts and out of that is 15. So probability of success is 0.6. So a fan thinks that he can do better than that. So it means that the direction will be towards the right. So when you define your H naught, your probability of success will be equal to 0.6, and your alternative hypothesis will be greater than 0.6. So this H1 usually is given by the question. So now you hit 15 times. So x will be greater or equals to 15. So this direction follows what the question asks you to test. So this will be px equals to 15 plus px equals to 16 plus px equals to 17. So this will be 17c15 times 0.6 power 15 times 0.4 power 2, and then 17c16 times 0.6 power 16, and then 0.4 power 1, and then you have 17c17, which is 1, times 0.6 power 17, and then 0.6 power 0, which is 1. So what you would get is 0.0123. So what you need to find? So you need to set 15 as your critical value and at one integer percentage significance level. So of course the significance level you have to set it at 2% or 0.02, because then your px greater or equals to 15 will be smaller than 0.02. perhaps I can put it here because. So that's why your significance level is 2%. Perhaps we should stop here and continue on tomorrow with the two-tailed test and errors. So that's all for today's video. Thank you.